question, the yield curve on an 6% bond redeemable in 5 years' time at its face value of 100 has the following term structure of interest rate as depicted by the yield curve. So again, as you remember, the yield curve of 6% bond means that the coupon rate of this bond is 6%. Redeemable in 5 years means that the time to maturity is 5 years. And the face value of the bond or the par value is 100. The following interest rates are spot rate, and they are basically the rates to borrow and lend for specific time to maturity. And basically, we can say that they are yield to maturity for zero coupon bonds. So if we have got a zero coupon bond with the maturity of 1 year, its yield to maturity is 4.2%. And if you have got a zero coupon bond with the time to maturity of 2 years, its yield to maturity is 4.4%. And remember, zero coupon bonds are the bonds that do not pay any coupon. And as an investor in those bonds, you just receive par value at the maturity. So here is very important to understand the difference between spot rate and yield to maturity. So a spot rate, generally speaking, is the yield to maturity of zero coupon bonds with a specific time to maturity. So the question asks you to estimate the value of bond and its yield to maturity. So let's go first and focus on part A, estimate the value of a bond. And let me back to the Excel file. All right. So again, here I brought the definition of the spot rate. The spot interest rate is the rate of return earned when the investor buys and sells the bond without collecting coupon payments. And that's a very important definition of finance, followed by yield to maturity. Yield to maturity is the overall interest rate earned by an investor who buys a bond at the market price and holds it until maturity. Basically, if you buy a bond and keep it until maturity, that's the overall interest rate you would earn. So in our question, we have gotten a spot rate for different years, 1, 2, 3, 4, and 5. And we have got the spot rate. Which are 4.2, 4.4%, 4.8%, 5.4%, and 5.8%. Right. So the question asks you to find out the price of bond in our question using the following rates, which are the spot rates. And first, we need to consider the present value of cash flows from this bond. And remember, we have got basically the following cash flows by investing this bond. The coupon is 6%, so 6% times par value 100 is equivalent to the cash flow we're going to receive every year. And I'm going to scroll down. But remember, at the end, which is the maturity, we have got another cash flow. So I'm going to separate it here, which is the par value. Okay, so That's why the year 5 repeated itself. You can simply say 106 rather than 6 and 100. So we are supposed to find out the present value of these cash flows first. And you know the present value is equal to the coupon over 1 plus spot rate in power of the time, which is 1 year from now. So 5.76. If I drag this small square in the right down uh, side of actually the cell, it would repeat itself and copy and paste the formula from the first cell to the down. So we have got the present value of the cash flows. And if I press auto sum here, we have got the price of this bond, which, as I said, is the present value of the future cash flows. So this is how you can find out the price of bond using basically spot rates. But remember, we can find out the price of bond using both spot rate and yield to maturity. All right. So um, there are, the next part of question basically asks you to find out the yield to maturity of this bond. And yield to maturity is the yield or the interest rate that you earn if you keep the bond for the whole 5 years, basically. So this is the overall interest you earn. And in Excel, we can find this rate by function rate. So the first item is N per, which is the number of period of investment or keeping the bond. To be more accurate, the number of coupons we receive, which is 5. The payment, here is the coupon, is £6 per period. So I put -6 because at the end I want to have a positive answer. And the present value is the current price of the bond, which is 101. This is the price we pay for this bond. And the future value is the basically the par value that we receive at the end. So the par value, I'll put it negative. So the cash flows, remember the cash flow, this is the amount of money we pay, the amount of money we receive. We can do it reverse. I can say this coupon is the cash flow I receive, so I put it positive, but the price of the bond is the cash outflow. I put it negative, and at the end we have got par value, which is a cash inflow, so I put it positive. So if you increase decimals, we have got an accurate answer. This is yield to maturity of this bond. So Excel helps to find out yield to maturity in a very accurate way. Although we have got other ways to, in the exam, for example, manually cannot find out the accurate answer. Excel uses trial and error approach, so it tries different rates to end up with this correct answer. So in case we want to use a manual approach to find out yield to maturity, we need to basically use two rates, which makes the price of bond very close to 101, the actual price of the bond. So let's try with the, for example, the rate 5.80%. If we try this rate and discount cash flows using this rate, let's see what is going to happen. So the price of bond present value would be equal to 5.8 as the rate, number of periods, which is 5, and the payments, which are -6, and the future value, which is minus 100. So the bond price would be so if the yield to maturity is 5.80, the price of bond would be 185. So as you see, 185 is lower than 101 actual rate. So there is a gap between these two. There's a distance. So what we need to do is to reduce yield to maturity. As you know, when the rate to maturity reduces, the price of bond increases. So if I copy this one to the right cell, let me see if everything is correct. So the rate here is T15. We have got 5.40. Yes, uh, that's correct. So 5.40, the price of bond would be 10257. So now we have got two suggested yield to maturities and their assigned or associated price of the bond, considering these two, but neither of them is equal to 101. So uh, we know that the rate, the actual rate, should be between these two, 540 and 580. So here we can use the technique of interpolation. And the technique suggests that start with the lower rate, which is 5.40, plus consider the gap between these two rates, which is 5.80% minus 5.40%. So starting with the lower price and lower yield to maturity 5.40, the gap between these two, 5.80 minus 5.40 times. What we do here, we start with the higher price, which is 102.57 minus the actual price of bond, 101.30, over the higher price, which is 102.57, minus the lower price estimated, which is 185. So basically, we need to type this formula in the Excel file to end up with a kind of approximate yield to maturity. So 5.40% plus the gap between these two, which was 5.80. I can simply put the cells instead, right? So equal 5.40 lower price plus the gap between these two, 5.80 minus 5.40 times, all right, 102 minus the actual one over 102 minus the lower one. And the answer is 5.69. So as you see, it's very close to the actual yield to maturity. So that will be the yield to maturity, estimated yield to maturity using interpolation approach, which, as you can see, it's very close to what Excel suggests. So this is the Excel rate. So I'm going to put a note here. This is the Excel rate. Estimated by Excel, which is very accurate. And this one is the basically rate, which is estimated by or let's call it yield to maturity, estimated by interpolation technique. All right.